So stop me if you heard this one, but a machinist walks by a part that has a hole in it, right? So he double takes, he looks at the hole and he says, I tap that. So our friend the machinist, to tap that hole that he likes so much, he would use a threading tap, right? But let's say that we, as CAD designers, we want to tap this 5mm hole with an M6 thread. How would you do that? Well, you need to design the profile and then helix and calculate everything. Or, you can create a Boolean subtract. You're not going to be adding any parts, going to the library, generate. We'll find our threading tab. Nice. Okay, let's let's bring that in and say we want an M6 by 1mm, not by 0.2. And let's say that we only want 10mm of thread for that hole. Okay, finish this. We go back into the Boolean to constraint, our Boolean tool, right? The other way around, like that. Now we click the bottom of the thread, the root of the thread, and the hole, right? And we hit apply, close, green check mark, and we have achieved threads. We have an M6 thread here, and actually, if we do a bit of time traveling and go back in time before the point that the thread was created and give it a bit of a chamfer here with a value that's just over half of the pitch, right, and regenerate, we've got an even better thread, I would say. Okay, so today I will show you how to make this very threading tab, and this has a lot of parallels to the threading die video I've done a while back. So if you want to watch, stop this video, go back and watch that one, and then you will see that this one makes a lot more sense. But so let's start making our threading die. As in the other case, I suggest that you make your parameters first. Of course, you can start sketching, then make your parameters, whatever. Okay, so first I'll make a parameter that's called mthread and give it a value of 6. That is going to be my nominal diameter, right? Not my actual diameter, my nominal diameter. Then I'll make another one that is going to be called pthread. That's going to be 1. That's going to be the pitch of my thread. And the length of my thread, which, for argument's sake, let's say that this is 10mm. Okay, so we have our main parameters, at least, right? You might remember from the other video, we'll need one more. But let's take it one step at a time. So we're going to make a circle here, and we will dimension it as mthread, which is our nominal diameter, right? Oh, sorry for that. Right, and we want this to be a reference line because we will not be using the nominal diameter to design anything. Now, we want to make another thread. We want to make another circle, and that is going to be the major diameter of our thread. So how do we calculate now the diameter for this one, right? We can reference back to this page, which is the isometric screw thread Wikipedia article, and it explains it very well, and it has this wonderful, wonderful diagram of the thread profile. Now, the thread profile in isometric threads and UTS threads is an equilateral triangle, right? So it's just a triangle that has every angle 60 degrees, all sides are equal, and they're all length P, where P is the pitch, right? And you will see that we need another value here, which is H, okay? H is the height of that triangle. And as I have explained in the other video, the height of that triangle is the cosine of 30 degrees times the pitch. Okay, so let's go back. So let's go and make that parameter, right? We'll make a new parameter. We're going to call it thread age. And we say that this is the cosine of 30 degrees times the pitch of the thread. Now, a small trap here, Alibre needs radians as the input argument for the cosine, for the trigonometric functions, right? So how do you convert a 30 into radians? You say 30 times 2 times pi, and you divide by 360, and you're good to go. We hit apply, and we see that, well, the pitch is 1. So basically this is just the cosine 30 degrees, which is actually 0.866. Okay, so now we have our, now we've got our thread height. What do we do with it? Well, going back to this image here, you will see that the very tip, like the very actual tip of that triangle, which is our nominal diameter, so that very tip of that triangle is the 6 millimeter circle that we have in Sketch. Okay, there is a difference in height of 1/8 of the thread height. Okay, well, that's cool. We can do that. Let's go define that in Sketch. So the way we define this in Sketch is we just say that the difference between these two circles is 1/8 multiplied by the thread height. Okay. So this is our actual major diameter of the thread, and we can also get a driven diameter going, because you know you can see the value if you want. Okay. Now here is a good way to control the tolerance of the fit, right? So if you want a more a looser fit, what do you want this major diameter to be? You want it to be smaller. So what you would do then, let's click that FX icon, go into the equation editor, and what I like to do is I like to create a parameter called tol from tolerance, right? Let's give that a value of 0.1. Too much, right? Let's give it a value of 0.01. Okay, so this, again, this is our major diameter now. If we want to make it looser, we need to make it smaller, so we need to subtract the tolerance. Okay, so now you see the tolerance has been subtracted. You can see what's going on inside the driven value here, and if I turn my tolerance to 0, well, I get everything nominal again, right? Okay, so that's how you control tolerances here. And now that we have the major diameter, we will just extrude the basic cylinder of our threading tab. So what is going to be the length of this extrusion? It's going to be the length parameter. Cool. Now we want to get a chamfer going, right here on the front. And how large is that chamfer going to be? Well, first of all, let's say that, yeah, we need an angle and distance. Okay, so let's get an angle of 60 degrees, and let's say that the distance is going to be 1 time the thread pitch. Okay, well, actually 30. Yeah, sorry for that. 30 degrees. Well, instead of changing that, I could have just left it at 60. Toggle the 3D preview, flipped it, toggle it back on, same result, right? Okay, so now, right, now that we've done this as well, now we're going to sketch in the YZ plane, and we're going to sketch our profile. Now we want to start, we want to position our thread profile on the chamfered edge. So we'll make it here. Now I could do 3 lines like I do in the other sketch, but here's another way to do it. You enter a polygon, you see that you need 3 sides, and voila, because again, the thread profile is just an equilateral triangle, right? Or a regular polygon with 3 sides. So this is our thread profile. And now we need to locate it. Well, first of all, let's reference the front face. Let's say we're going to start from here. Okay. Did I make this? No, this is correct. Okay. And now we want to go back to our thread profile and see what dimensions exactly we will be using. So we see now here that from our nominal thread height, which is the 6 millimeters, right? We want this thread to be 3/4 of the thread height. That's how much we want to be forward, right? So how are we going to do that? Well, now let's repeat what we need. We need our profile to go down 3/4 of the thread height and then have a flat, okay? And also start at the nominal diameter. So let's go back into our sketch and apply all of these requirements. So first of all, this side needs to be at the nominal thread diameter, but because we're dimensioning from the center, we need that radius, okay? So now that's at 3 millimeters. Okay, you can see that we still have, let's make it bigger. We still have a bit of air going over it, right? That's the major diameter tolerance we built in with our first sketch. So we need a second thing here, which is what? We need a flat spot here. So how do we do that? Well, we take these two, make it into reference lines. I'm using my hotkeys. I've got a video on what they are, right? But you can also hotkey a button of your own. It's just this command. So convert to reference figures, you can hotkey that command. So that's what I did. And I just take a line, trace this one, draw the flat, go back. Okay, and now I can have this 1/4 of the thread height tolerance there, right? So I will say that this is 1/4 multiplied by the thread h value. And again, here is a spot where you can define your tolerances. Okay, so if you want a looser thread, you would want a deeper root, right? So you would want this height to be smaller. So I will again subtract my tolerance. Okay, and finally, and most importantly, we say that this side is equal to the pitch thread. Okay, and this is it. Okay, now this is the correct profile and it's also located correctly, and we're done. So what are we going to do with that thread profile? We're going to do a helical cut. Okay, we need a height and pitch type. Sure. We need the reference line. Well, we can take the outer face of this. You see that the helix is going off. It's going off the wrong direction. So I'm just going to hit reverse here. So the height is going to be the length, but because I want this, I want to be sure that I'm cutting everything that I need to cut. I'm just going to give it a bit of extra twice the thread pitch. And the pitch of the thread is, you guessed it, the pitch of the thread, right? There you go. Now, if we were making a taper tab for an NPT type thread or whatever, here's where you would insert the tapered angle and you would have a parameter for that. We hit OK. Now you can see that we have this very lovely thread formed. Okay. Now we created everything based on the M6x1 thread. Now, um, so here's a tip, because I fell into that trap so that you don't have to. When you're generating these parts, the generator is going to take the first value for the threads, for the nominal thread, and it's also going to take the value that was saved for the pitch. So if we start from an M1 thread, let's say, it's going to try and create an M1 thread with a 1 millimeter pitch. And that doesn't go well. It hangs for quite a while and then creates a rubbish shape, and then you can select your parameters. It's just wasting time. So what we're going to do now is we're going to change these. Well, let's make these our favorite parameters, and let's sort by favorites. So now we've got it on the top here. Well, this doesn't need to be a favorite because it's a driven parameter. Okay, so make sure that when you save this, it already has the smallest nominal diameter that you want to be using. So I'll start with a 1 millimeter nominal diameter and a pitch of 0.2 millimeters. And, tolerance of 0 is fine for now. So let's hit OK. So this is the part I'm going to save. Save it along with my other files. And I'm going to call this Boolean tab. Now that I've saved it, I can make a library entry out of it. So I go to library, and to library, I tell it what parameters I want to bring in. Well, definitely I want to bring in the thread pitch and the thread nominal diameter and the length. And here's the length. Now, if you want to control the tolerance of the thread when you're generating, you can also bring this in. Generally, for 3D printing, there will be a set value that the tolerance works well at. So you can hard code that in, and you don't need to change it there. Plus, after you save everything and an instance of this threading tab has been created, you can open that instance and change the tolerance. So this is what I'll do. I'll hit next, and here is the parameter table for this part. You see the display order and the display name. Well, display order, I want to be picking this first, then the pitch, then the length. Display name, I'm not going to be inputting values directly to this, so I'm not going to bother. I am going to be inputting directly to this, so I want to say that this is the pitch and this is the length. Okay. So why am I not going to be inputting parameters directly here? Well, because in metric threads it would work, right? So the nominal diameter for an M6 thread is 6 millimeters. But, there are other types of threads that the nominal diameter does not match exactly, that. For example, quarter 20 or whatever. So what I'm going to do is I'm going to make an additional parameter, and that is going to be my nominal diameter. Oops, sorry, nominal diameter, right? And this is going to be a simple text and numeric input type. And here I'm going to input the names of the catalog of threads I will have available. So I will have an M1, I separated by a semicolon, have an M2, M3, Okay, I have made my catalog of values here, and this is what is going to create the drop-down menu you saw in the beginning. So how will I use that? Well, I go into this mthread parameter and I select the input type value driven. And what's going to be, so I click to edit, and it's asking me which parameter is going to be the driving one. Well, it's going to be this parameter that I just made, the nominal diameter. So you hit plus, and you add a value, and when the library sees the value m1 in the nominal diameter parameter, it will input the value 1 into the mthread. So this is how you can create a drop-down with text that you can then convert to a numerical value. And every time you hit the plus mark, if I hit in the value box, it will just give me the next one in the list, right? So I go through and I populate everything. Hit OK. Now, here's the problem with it. When you are driving a parameter with a different one, Alibre likes to have the driving parameter be defined before the driven one. So in this display order, you need the nominal diameter above the mthread parameter. Okay, so we hit next. Oh, right. It says that it needs values here because I forgot to insert the correct input type. So this is going to be just a numeric user input, and this is also going to be a numeric user input. Now let's hit next. Okay, and now it's asking me where to place this. I want to place this in this file, in this folder, sorry. I hit finish, and that's it, guys. Now I have a threading tab, and I can use it just like you saw me use it in the beginning. Okay, so let's go make an example. So let's delete this Boolean operation, and let's go and remake it with the threading tab we just created. So Boolean subtract, we're not adding any files from from our drives. Go here, we call this one Boolean tab, that's the one we're selecting. Let's place it here, we only need one, and it's going to be an M6 by 1, and it's going to have a length of 10. Again, this is exact same thing you saw me do at the beginning, right? We're just using the Boolean threading tab that we just made. Okay, I hit on the root of this thread so I can get a coaxial going. Not offset, zero offset. Okay. And we're good to go. Hit the green check mark, and we have achieved our threads once more. So this is it. Now you have not only a Boolean threading die, but also a Boolean threading tab. So when you see a hole, now you can tap, just like our friend the machinist. So if you like this video, please subscribe, hit that like button, and if you didn't like it, hit the dislike button because I still need to know. And I hope I see you in the next one.